In this problem, we're going to calculate the pH at the equivalence point. So here our moles of sodium hydroxide should be equal to the moles of acetic acid. And so we're going to start this problem exactly the same. So I'm going to turn off my video and let you follow along. So everything looks normal up until this point, but what we see here is that my reactants have been completely used up. And that makes sense. I'm at the equivalence point. Those two reactants should have canceled each other out completely. So all I'm left now is with my products. But what's special about this situation is my product, unlike with a strong acid, strong base, my product salt is able to hydrolyze. Since my anion is coming from the conjugate base of a weak acid, my anion is capable of hydrolyzing to produce hydroxide ions. And so what we're going to do now is just treat this as if I have a solution of 0.0500 molar acetate ion, and we're going to calculate the pH of that solution. So I'm going to set up an ice table to show the hydrolysis of acetate ion. Now the next trick that comes into play here is remembering that acetate ion is a base, which means I actually have a Kb expression, which I can calculate the Kb by doing the Kw divided by the Ka for the conjugate acid. So the conjugate acid of acetate ion is acetic acid. So my Kb will be 1.00 times 10 to the minus 14 divided by 1.8 times 10 to the negative 5. That should equal x squared over 0.0500. So we get our hydroxide ion concentration being 5.29 times 10 to the minus 6 molar. Remember, if I want the pH, I need to do 14 minus the pOH. So I'm going to do 14 minus the negative log of that answer to get 8.72. For a titration involving weak acid with a strong base, the equivalence point is going to be greater than 7 since the anion of the salt product will undergo hydrolysis and produce hydroxide ions.